Today we will discuss operators and expressions in C language. An operator is a symbol that tells the computer to perform certain mathematical or logical operations. Operators are used in programs to manipulate data and variables. They usually form a part of mathematical or logical expressions. So example, very simple example for an operator is plus, then minus, then star, then slash. All these are operators. And when we give a simple assignment, say C is equal to A plus B, that means you have values for A and B. Either we will give assign value or they can get the value from the user. So A, B we have value and A and B are added and the value is stored in C. If this be the case, A and B, they are called operands. A and B are called operands and plus is the operator here. So we are learning about the different operators. Okay. See, operators can be classified into a number of categories. One is arithmetical operators, then relational operators, logical operators, assignment operators, increment and decrement operators, conditional operators, and bitwise operators. So these are various types of operators. We will learn it one by one. Okay. Arithmetic operators. The commonly used arithmetic operators are plus for addition, minus for subtraction, star for multiplication, slash for division, and percentage, that is modulo division. This is used to get the remainder in division, and this is commonly used with the integer data. Okay, because when we divide, say 6 divided by 4, what will get 4? Here quotient is 1 and the remainder is 2. But if we do continue with the division, what will happen? After putting a decimal point, here you have this. So this is 1.5 is the quotient. So it depends on the data type. So if I say like if my result of float A slash B, float of A slash B, what will happen? It will be float type, so it will be 1.5. In that case, there won't be any remainder. So only if int A and int B, then A percentage B will give the remainder. So to get the remainder, A and B should be integer, then only you will get the remainder. Okay, so for getting the remainder, we use modulo, that's called modulo division, that we use percentage symbol. So A plus B, A minus B, A star B, A slash B, and A percentage B. So here, if A is equal to 6 and B is equal to 4 and they are int type, okay, if that be the case, then A slash B will give the quotient, that will be 1, and A percentage B will give the remainder, that is 2. So that's the difference between slash symbol and percentage symbol. Now integer arithmetic, let's take to values. Say let A be 14 and B is 4. We can simply calculate all this. So addition, subtraction and multiplication are quite clear. No need of explanation. But when we divide 14 by 4, what will happen? It will be like this. So 3, that is the quotient part. A slash B will give the quotient and A percentage B will give the remainder. So it's more clear. So these are the main arithmetic operators. Arithmetic operators are plus, minus, star, slash, and percentage. Now dealing with the real numbers. Real numbers means they allow decimal point also. So arithmetic operation involving real operands is called real arithmetic. So you can check the result here, 6 by 7. It is taken up to 6 decimal. After decimal point there are 6 digits. So maximum precision is obtained. So these are the arithmetic operators. Now moving on to relational operators. Relational operators means a relational expression is evaluated as either 1 or 0. Okay. So 1 means it shows that it is true and 0 means it is false. So these are the operators: less than symbol, less than or equal to, greater than symbol, greater than or equal to. So we, in our notation, we write it like this for greater than or equal to, but for in C language, how we write greater than or equal. Similarly, less than or equal to, in C we write less than or equal. Not equal we write like this. In C we write it as not equal. This is the exclamation mark. So we should learn relational operators. And this is, it's not a single equal. This means this is assignment operator. For example, C equals A plus B. This means that A plus B value is assigned to C. But when we write C equals A plus B, that means it is checking if this value and A plus B value are equal. So double equal means it is checking whether they are equal. So you can check this: 4.5 less than or equal to 10. Yes, it is less than 10. So it is true. 4.5 less than minus 10. That is false. Minus 35 greater than 0. It is false. 10 less than 7 plus 5. Yes, 7 plus 5 is 12. 10 is less than 12. It is true. A plus B is equal to C plus D. It might be having prior values, and let it be true. So true value solved will be evaluated as 1 and false value will be evaluated as 0. Now coming to logical operators. Logical operators mainly they are and, or, and not. So for and symbol you have to use double and, or two symbols, pipe symbols, then not equal to their exclamation mark. You can check the example. If we need a condition like this: a greater than b and x equals 10, that this means if a is greater than b, this value will be 1, and if x is equal to 10, it's checking. That's why 2 equal is coming. X is equal to 10, what will happen? If both these conditions are satisfied, it has to go for any decision. So if both should be satisfied, and means this should be 1 and this should be 1. Only if both are 1, output will be 1. So this is executed only if both conditions are satisfied. That case we use and. And symbol is double and symbol. But if the number is between 0 and 100, if you want to represent that a number should be between 0 and 100, that means number should be greater than equal to 0 and number should be less than 100. So if this be the case, we normally write it as if num greater than 0, it should happen, and also num should be less than 100. This means it will be a value between 1 to 99 because it is greater than 0 and it is less than 100. Okay. If you need to include 100 also, you should write like this: num less than or equal to 100. And here what is the meaning? If number is less than 0 or number is greater than 100, this means this range is excluded. Okay, this is excluded in this case. If number is less than 0 or number is greater than 100, if that be the case, values outside this range, you can like print an error message like printf. It is outside the limit like that. So you should be very careful when you write these conditions. In case of or, both need not be 1. If either this happens or this happens, output will be 1. You know, you might be remembering that and truth table 0 0 0 1 1 0 1 1. If these are the two inputs, then all these will be 0. Only if both inputs are 1, then only output will be 1. So in AND condition, both conditions need to be satisfied. But what about, so in this case, this is the symbol. But what about OR? OR is the symbol. For this, if either of the input is 1, definitely output will be 1. So you should remember that. It's given here. This is the result of AND. This is the result of OR. If either of the inputs is 1, output will be 1 in case of OR. But in case of AND, only if both inputs are 1, output will be 1. Non-zero means it is 1. Now assignment operators, we know that when we write C is equal to C plus A, C is equal to A plus B, here A plus B is evaluated and that value is assigned to C. So it's equal symbol. Now one thing we need to know is V operator equals expression. You can write like this. For example, C plus equals A means C equals C plus A. Both these are equal, that's given here. A equals A plus B can be written as A plus equals B. This means that A equals A plus B. Okay. So when we need to calculate sum of many numbers, we keep on adding to sum. So sum equals sum plus num. That be the case, how we can write sum plus equals num. So both these are equal. This is also valid, this is also valid. So you should learn this. This is the syntax where OP is operator. So this is called shorthand assignment operators. A equals A plus 1 can be written as A plus equals 1. A equals A minus 1, that is A minus equals 1. A equals A into N plus 1. A star equals N plus 1. Again A equals A slash N plus 1. A slash equals N plus 1. A equals A percentage B. A percentage equals B. All these cases you should remember that the resultant variable and the first operand should be same. Then only you can go for this shorthand assignment operators. To get the square of a number, how we can write A equals A star A. A star equals A. To get the square of a number. Next comes increment and decrement operators. It allows to increment or decrement a particular variable value by 1. That is plus plus will add 1 to the operand and minus minus will subtract 1 from the operand. So it's a unary operator. For example, let A is 5, then plus plus A will become 6. If A is 8, then minus minus A will give you 7. There's something which we need to learn in detail, so it will be discussed later with the help of programs. So let's move on to the next topic, and after that we'll come back to this because there is something called pre-increment and post-increment. Similarly, pre-decrement and post-decrement, and you can get many questions from that area, so we can discuss it later in detail with programs. So we'll right now complete this topic. So rules for evaluating various expressions. First, parenthesized sub-expression from left to right are evaluated. We know that when we evaluate an expression, there will be different operators. So there is a priority. So those calculations that need to be calculated earlier should be enclosed in brackets or parentheses so that it will be executed first and then it will be evaluated from left to right. And if the brackets are nested, what will happen? The innermost bracket will be the expression in the innermost bracket will be calculated first. Then precedence rule is applied in determining the order of application of operators. We know that in simple mathematics we learned it is division, multiplication, addition and subtraction. Like that here for all the operators there is a rule of precedence. So in that order only expressions will be uh, evaluated or calculated, and if you need a change in that we have to properly use brackets or parentheses. They are normally evaluated from left to right using the rules of precedence. When brackets are used, expressions within the brackets will assume highest priority. And this is a rule for evaluating or calculating various expressions. Next is conditional operator. Conditional operator, it consists of set, question mark and colon, and this is the syntax. We can write an expression first and that is verified. If it is true, for example, A greater than B. So if A is greater than B, it is a true statement. Otherwise, it's a false statement. If it is true, it will be 1, and if it is false, it will be 0. So first expression 1 is evaluated, and if it is true, it will go for the first case. If it is not true, it will go for the second case. It will be more clear with an example. You can check this. Here A is 10 and B is 15, and X, we are trying to find out the value of A. First, there is a condition A greater than B. If it is true, it will be 1. Here A is 10 and B is 15. So this is false. So it will go for the second condition, that is B. So now X equals B is assigned. Okay, so in a single step it is calculated. If A is 15 and B is 10, what would have happened? This condition is true. So A value would have been assigned. Here this is not true. So second choice, that is B, is assigned to X. If else we have not covered, we will discuss it later. Otherwise, it can be, this part can be implemented using if else. It will be like this: if A greater than B, X equals A, else X equals B. So this is a more common method of coding. Still, you can understand how we use this conditional operator. So this is expression 1, this is expression 2, this is expression 3. So it is in conditional operator, it is checking for it evaluates an expression, and then there is a question mark, then say 1, condition 1 colon condition 2. If we write like this, if expression is true, it will go for condition 1. If expression is false, it will go for condition 2. So this is how this conditional operator operates. First condition only if the expression is true. Otherwise, it will go for the second condition. Then bitwise operators are there. We know that it's bit means a single bit. For example, if I write say A equals 4, in binary it is 0, 1, 0, 0. Similarly, if B is 6, it will be 0, 1, 0, 1. So bitwise operations are performed with bitwise operators. Okay, and normally it is not applied. This is an important point. It's not applied to float or double with the because they are having decimal points. So that is generally this is operated with integer only. It's used for testing bits, shifting, and applying logical operations like and, or, and not. So you can just learn this in bitwise operation, bitwise and, perform bitwise and, you can use this operator for or, for exclusive or. Hope you remember the truth table. In case of and, bitwise. So anyways, it's dealing with bits. 0, 0, 0, 1, 1, 0, 1, 1. If these are the inputs, say x1, x2, what will be the output y? And is high only if both inputs are high. In the other three cases, it will be 0. When it comes to OR, x1, x2 are inputs and y is output. 0, 0, 0, 1, 1, 0, 1, 1. We know that if either of the input is 1, output will be 1. So only in this case, output is 0. All the other cases, output will be 1. Then bitwise exclusive OR. How to calculate exclusive OR? Again, two inputs, say x1, x2, 0, 0, 0, 1, 1, 0, 1, 1. What is the output of XOR? The output of XOR will be high only if inputs are different. So in this case, 0, 1 and 1, 0, output is high. If the inputs are same, output will be 0. So for exclusive OR, you can do this. This symbol is used. So what is done is, say A, B, let it be int A, B, and either user can give the value or you can assign the values. And when you do, say C is equal to A and B, or A or B, or A XOR B, when you do all this, what will happen? Bitwise they are operated. Okay, the corresponding binary value of A and corresponding binary value of B are taken, and bitwise they are operated. So that is the significance of bitwise operators. Then what about shift left and shift right? It is like A, let it be 4 or 6. It has a corresponding binary value. When you write A shift left 1, what will happen? This is the operator for shift left. Bits are shifted by 1 bit to the left. Similarly, for shifting right by 1 bit, you write like this. A right shift 1. And if you need to shift bits by 2 positions, you can write either A left shift by 2 or A right shift by 2. So to how many bits it should be shifted, that is given here, and this is the operator. So now we are just familiar with bitwise operators, and, or, XOR, then shift left and shift right. So all these are the bitwise operators. And now let's see. Till now we used only the standard input output header file, that is stdio.h. Okay, and another thing is math.h header file, which includes many mathematical functions, and here they are. These three values, say sin x, cos x, and tan x, they will give the trigonometric functions. Sin, cos, and tan of x can be calculated with this function. Then for finding the log to the base 10, you write like this. For natural logarithm, log to the base e, you can plain function is log x. If base is 10, you have to specify log 10x. All these functions are defined in math.h. So when you write a program, if you have to use any of these functions, what you have to do is, in addition to the first statement, say hash include stdio.h. This is how you add a header file. In addition to this, you have to add this header file also. Hash include math.h. Only after this, when you use any of these functions, it will be meaningful or it will be executed. Then to round up to a nearest integer, it is ceil, and for rounding down it is floor x. For example, after adding this header file ceil 4.3, it will be 5. It will be rounding off to the nearest integer. It is rounded up to the nearest integer. Same thing, floor 4.3, it will be rounded down, so it will be 4. This is the difference between ceil and floor. Then to get the absolute value of x, that is excluding the sign, for that to take the absolute value, FABS, that is a function. Then power of, say, 3 raised to 5. If you need to calculate 3 raised to 5, you can write, say, answer or C. A variable should be assigned. C is equal to power, POW 3 comma 5. This means 3 raised to 5 is evaluated and it is saved to the variable C. Then to calculate square root of x, you can directly write SQRT of, say, 7. This, to get this square root of 7, you can write like this, and you have to assign it in a variable, say d is equal to square root of 7. When you calculate square root of 7, make sure that this variable will be float or double, because we know that when we take square root, it cannot be an integer always. So you can uh, define the define the variable as float or double. Okay, so all these are the common math.h functions that we need to use. Thank you.